Our next topic for the semester is going to be probability. So we're going to spend a while talking about how we calculate probability, how we use it, some kind of important examples of how it's used. So just to start things off, let's talk a little bit about what probability is. So the idea of probability is the probability is a number between 0 and 1, or between 0% and 100%. So remember, 0 is 0%, 1 is 100%. So this is just saying the same thing. Depends. Sometimes we talk about it one way, sometimes we talk about it another. That represents the likelihood of something occurring. Okay, so 0 are 0%, meaning that it absolutely will not happen. 1 or 100%, meaning that it absolutely will happen. And then all of the other numbers give us a range to kind of say, oh, well, how likely is it to happen? So is there a 50% chance? Is there a 70% chance? An 80% chance? So that's what probability is. Now, probability is used in a number of different ways. We're going to focus mostly on what's called theoretical probability and experimental probability. So I want to define those two, and then we'll talk a little bit about what's called subjective probability. Okay? So the first two are the ones that we're mainly going to discuss. They're the ones that we're mostly interested in. So theoretical probability is the theoretical chance of something happening. So if you have a theory about how something works, so for example, say you flip a coin. Now, we have a theory that if you flip a coin, it is equally likely to come up heads and tails. Now, is that true or not? Mostly true, right? Again, if the coin is damaged in some way, it's not exactly going to be true. But the theory, this perfect ideal coin, has a 50% chance of coming up heads, a 50% chance of coming up tails. That's theoretical probability. Okay? Experimental probability is where we take a coin and we flip it, say 1,000 times, see how many times it comes up heads, how many times it comes up tails. Now, again, this coin, because we know that a coin flip should come up 50% heads, 50% tails, we think that's true. If we flip a coin 1,000 times, the experimental probability should be close to the theoretical probability. So maybe you flip a coin 1,000 times and 512 times it comes up heads and 488 times it comes up tails, right? That's pretty close. 51.2% versus 48.8%. Those are pretty close to 50%. And kind of, there's a whole area of mathematics that kind of describes how likely an experiment is to come up close to the theoretical probability. And that area is called statistics, and we're going to talk about that next, though maybe not in that same kind of detail. Okay? So theoretical probability comes from a theory. Experimental probability comes from data you collect. Okay? So sometimes it can be tough to tell what something is. So for example, if you're watching a weather report, the meteorologist might say there's a 25% chance of rain on Thursday. And you might say, well, I don't really know necessarily what that is. That's theoretical probability. So they're saying we've studied all the meteorological theory, and we think that it's 25% likely that there will be a rainstorm on Thursday. Experimental probability would be if you go back and look at all the data that's been collected for the last 30 years in Baltimore or wherever you are, and say, oh, it's rained on 25% of the days, so there's a 25% chance that it rains on any given day, right? That would be experimental probability, okay? So we're not necessarily going to worry about figuring out the difference, but I just want you to know about both of them, okay? The last one here, subjective probability, this is an educated guess. Well, educated or uneducated. Guess. And you hear subjective probability a lot. So, for example, if you go to the doctor and you've got a runny nose and a headache, and the doctor might say, I'm 99% sure that this is just a cold and that you just need to rest, right? Now, is the doctor saying that I know some advanced medical theory that says in 99 out of 100 cases this is a cold, or are they saying I've conducted an experiment and 99 out of every 100 patients I see this is just a cold? No, they're really making a subjective call. They're saying it's 99% sure. Now, is that number going to be exactly correct? No, but it's meant to reassure you. It's meant to say, this is kind of my opinion. And in the doctor's case, that opinion is educated. Somebody else might say, I'm 95% sure that you have cancer. If that person's not a doctor, then that's an uneducated guess. So subjective probability is really just somebody kind of assigning a probability. It's not really actual probability, but it can still be useful. Okay, so we won't talk as much about it, but people do use this all the time, so you should be aware of when they're talking about subjective probability. Okay, so let's talk about how we compute probability. We're going to start with theoretical probability. So just a little bit of terminology. So we say that the probability of an event occurring is the number of outcomes in that event divided by the total number of outcomes as long as all outcomes are equally likely. Okay, so let me explain kind of what this means. So when we talk about an event in theoretical probability, an event is a collection of outcomes. Okay? And an outcome is, as is kind of said here, is any of the possible results of whatever we're doing, as long as those are all equally likely. Okay? So let me give you an example of this, because this seems really technical, but it's not actually that bad. So just an example here. If you roll a 6-sided die, what is the probability you get an even number? Okay? So in this case, The event that we're looking for the probability of is getting an even number. Okay? But we're going to think about that event as a collection of possible outcomes. So what outcomes match this event? Well, if you roll a 6-sided die, you can get a 2, a 4, or a 6 are the possible outcomes where you get an even number. Okay, so that matches, if you get an even number, it's either 2, 4, or 6. So we're going to take the number of those outcomes, the number of outcomes in the event, divide it by all the possible outcomes, the number of all the possible outcomes, right? So there's 6 different possibilities if you roll a 6-sided die. And so we get 3 out of 6 is the probability of getting an even number. There are 3 outcomes that match the event out of 6 outcomes total. So that's all that this is saying. And so, like I said, it looks a lot more complicated than it actually is, but it's not so tough to work with. Okay? So, you can do this in a lot of different cases. Let me give you another example where maybe this is a little bit trickier to figure out. Let's do another one of these. So let's say that you roll 2 dice, and what is the probability you get values that sum to 6. Okay, so what's the probability that these 2 dice that you roll, that they add up to 6? Well, this is more complicated because there's a lot more different outcomes here. Okay, so if you're thinking about rolling 2 dice, you've got 6 possible numbers on the first die, 6 possible numbers on the second die. And so if you think for a second, and we'll talk more about this when we talk about counting in a bit, there are 36 different possible outcomes. Okay? And so if you want to think about why this is, there are 6 for the first die, there are 6 for the second die. So you could have like a 1 on the first die, and then either a 1, 2, 3, 4, 5, or 6 on the second. So that's 6 possibilities where the first die is a 1. There's going to be 6 where the first die is a 2, 6 where the first die is a 3. You can also think of, that's 36 different possible outcomes. We'll talk about that more in a little bit. Which ones of these give you values that sum to 6? Well, if you think about writing down pairs, where you've got what you get on the first die and on the second die, which ones are going to give you things that sum up to 6? Well, a 1 on the first die and a 5 on the second die would sum up to 6. A 2 on the first die and a 4 on the second die. A 3 on the first and a 3 on the second. A 4 on the first and a 2 on the second. Now notice that even though when we rolled the dice, 2 on the first and 4 on the second, 4 on the first and 2 on the second, you might say, well, that's the same thing, right? That's still going to look exactly the same when we roll them. But we need to be careful here to treat these as different outcomes, because we want each of our outcomes to be equally likely, okay? And so if we treated these as the same, it doesn't matter if you get a 2 on the first and a 4 on the second, or a 4 on the first and a 2 on the second, that's going to be twice as likely to occur, because it can occur in 2 different ways, okay? So we need to treat these as separate different outcomes. And so one last one, a 5 on the first die and a 1 on the second die. So these are the ones that match our event. And so 5 match our event out of 36 total. Okay? And so that gives you the probability. The probability of rolling 2 dice and getting 2 dice that sum up to 6 is going to be 5 out of 36. Okay? In our next video, we'll talk about some more complicated ways of combining probabilities.